Right. How are you, grade 12s? Makore. I'm going to take you through the session on functions and graphs. Now, functions and graphs is not something that is starting um, in grade 12. It's something that you guys acquired from as low as grade 8. Right. Now, it is your first section that you're supposed to cover in your second term. And I'm going to break it down, starting from the basic definitions that you need until the last technique that you expected to acquire in this grade. An exciting topic, a beautiful topic. How I urge you that you guys continue following EduBlush, a virtual academy. Okay, EduBlush Virtual Academy, just for a background, is a visual school. We are going to be presenting all the topics that you need in mathematics, physics, accounting, and many more learning areas that you might be struggling with. So I urge you guys to follow us as we'll be going through your, your different learning areas. Okay, right. So let me take you to the board so that we can start quickly with what is expected of us in this section. Okay, right. Um, okay, now under this section, there are a lot of things that we've covered. There are a lot of things that we covered from the lower grade. That's your grade 11. I'm sure if you look at this section as function and graphs, the bulk of the things were covered actually in your grade 11. The bulk of your things were covered in what? In your grade 11. But trust you me, I'm going to take you through take you through almost everything that you covered in grade 11, linking it up with what you expected to understand in in your grade in your grade in your grade 12. So let's let's move together. Please try as much as possible to follow, ask questions wherever possible, forward it to us. We'll try to answer it and convince you at your at the possible convenient time. Okay, right. So I'm going to look at the functions and your graphs. Allow me to write here functions and graphs. Functions and graphs. Right. Functions and graphs. Right. I'm going to look at the functions and graphs. Functions and graphs. An exciting section. Let's try to unpack it together. Right. Now, we are going to be looking at the functions. A function is always a composure of x and y, right? And a graph, it is the connection of the ordered pairs that are coming from the x and the y values that you have. Now, the first thing that I'm going to define with you now is what we call a relation. Okay, right. I can't speak of functions if I do not know what a relation is. So I'm going to start with um, a relation, and I'm going to define my relation as any collection, any collection of ordered pairs, any collection of ordered pairs, or you can call it points. Right. In the lower grade, you were taught that an ordered pair is constituted by what? An x value and a y value. In other words, a coordinate. So if I've got a point like x, y like that, that's an ordered pair. Means say there's a particular x value associated with a particular y value in that Okay, so basically I'll define my relation as what? A collection of any ordered pairs or collection of ordered pairs or points. Right. Now, I'll take you to your Cartesian plane, which is something like this. Look at your Cartesian plane. Call this one the y-axis, call that one the x-axis. Right. If I come to my Cartesian plane and I've got points, these are my points that are just, these are points that are scattered on your Cartesian plane. Right. Now, all these points, they'll formulate what we call a relation. Right. They are going to formulate what we call a what? A relation. Right. A relation. Right. They are going to formulate what we call a relation. So if I join these anyhow, I'll come up with, I'll come anyhow. You can go like this, then there you go, like that. Right. Anyhow, this is a relation. Right. They are what we call regular relations and they are what we call irregular relations. Regular relations are those relations that we've now identified and we commonly use them, like a linear relation, a quadratic relation, hyperbolic relation, an exponential relation, right? All those are now ordered. Those are now regular relations. Okay, but just for starters, let's just look at that graph and say this is a collection of any ordered points. I've managed to join them, either joined or not joined. They still remain a what? A relation. Now, I'll start now by saying that I'm now going forward to say, then what is a function? You guys have been using this word function from grade 8. You were told, function, teachers will be telling you, this is a function, this is a function. Now, what is a function? In its proper definition, as someone who's now set to go to varsity, someone will ask you, what is a function? You're talking about an exponential function, you're talking about a quadratic function, you're talking about a linear function, but what is it? How do you define a function? I generally define a function as a function. A function is a function is a special. This is a special type of a what? A relation where at least one element of the domain is associated or mapped associated with a unique, I'll underline the word unique, element of the range. A function is a special type of a relation where at least one element of the domain is associated with a unique element of the range. Okay, on any ordered pair, there is an X entry. An X entry falls under what we call the domain, right? And it's mapped onto a Y element, which is called what? The range. Okay, right. So we are talking of a function here, and we are saying it's a special type of a relation. So all functions, they fall under what we call relation. A relation is now a umbrella term. Under relation, there is what we call a function. A function is a special type of a what? Of a relation, where at least one element of the domain is associated with a unique element of the range, but not vice versa. But not vice versa. I'll come to that. I'll come to that. So for now, let's just take it like that. Okay, I'm now starting with a basic illustration. Let's look at this. Let's look at this. Okay, now just an illustration. I'm looking at this as a function, x plus a 2, y equal to x plus a 2, right? In basic term, algebraically, we're just saying, from a algebraical perspective, we just say any relation, any expression with x and y, we call it a what? A function. Okay, now look at this. Look at this, right? I've got a function like that. That's a linear function. Okay, in that arrangement, we call it a what? A linear function, because the highest exponent of x there is 1. All right, now look at this. Look at this. I'm going to come up with what we call the domain. Domain, these are the x entries, which are also called the independent variable. Okay, meaning to say, we are going to randomly pick any value, then we give it to x, right? Then we come up with what? With the range, right? The domain from your lower grades, we're calling them the input, and the range, they were also called what? The output. Okay, right? That's the output. There you go. There you go. Good. Right. Now, this is a machine. This is your function f of x. This is the algebraic arrangement which relates x and y. Right. So if I'm given something on the input here and say this is a 2, 1, 0, 1, -1, and -2 this side. Right. Then I'm going to go to my function or the machine, and I'm going to substitute wherever I see x, I'm going to plug in what? 2. What is going to be the output? I'm going to take 2, plug it where there's x, it becomes 2 plus 2, which will give an output of what? 4. So we are saying this 2 is mapped onto 4, which is now an ordered pair of what? 2, 4. In terms of ordered pairs, these are just coordinates. So it's now 2, 4. Allow me to write it like that. This means an x value of 2 is mapped onto 4. Okay, right. What about 1? If I put 1 there, you put 1, it means 1 is mapped onto what? 3. Put 1 into the machine, it becomes 1 plus 2, which is 3. So this is the output. 0 and that, it means this is going to be what? Output of 2. Something like that. -1 is mapped onto what? Put -1 there, is now mapped onto 1. Okay, what about -2? -2 is now mapped onto what? 0. If I put -2, that will give you a what? A 0. Now, if you look at this closely on your ordered pairs, this is going to be what? 1 mapped onto 3, 0 mapped onto 2 or associated with 2, -1 mapped onto 1, -2 mapped onto 0, right? So if you look at these ordered pairs and the domain and the range there, you can see that one element of the domain is associated with what? One element of the range. What I mean is, when I substitute there, I'm going to say what? One element of the domain, one unique element on the domain is giving out one unique element on the range. So such type of a relation or such type of a function, we call it what? A one-to-one function. Let me put a conclusion there. Such type of a function, we call it what? A one-to-one function. One-to-one function. Why is it called what is a one-to-one function? We call it one-to-one, meaning to say one element of the domain or the input, one element found in the domain is associated or mapped onto one element of the range. Good. Look at this. One element which was 3, which was a 2 for the first one, is mapped onto one element of the range, which is 4. So we call it one-to-one function. Okay, so that's the first type of a function that we have. Let's come to the next illustration. On my next illustration, I'm going to say, I'm going to look at another function here. Let's look at this as an illustration. Right, I've got something like this. This is going to be y equal to x squared plus a 2, something like that. Okay, I'm also going to come, right, if you look at the previous one, we're talking about a one-to-one function, and I gave you an algebraic expression which was a linear setting, and a linear setting or a linear function is under what we call a one-to-one function, meaning to say one input brings out one output. Okay, right, now let's come to this one. I'm sure you can identify this as a quadratic expression, right? If it's a quadratic function like this, I'm going to say, let me take the input, call them the domain, right? There you go. I'm going to pick values for my domain, throw them into the function, and come up with the output, which we are calling the range, right? There you go. Right, I've got something like this. The first input value that I'm going to use is, say, -2, -1, 0, 1, 2. Right, I'm now going to substitute -2. If I substitute it where there is x squared in the expression given, it becomes -2 all squared. -2 all squared gives you 4. 4 plus 2, it will give you 6. Okay, -1 into the function, you get -1 all squared, which is 1 plus 2, which will give you a 3. 0, plug it there, it becomes 0 squared plus that, which will give out a 2. Right, 1, if you put 1 there, it's what? 1 squared plus a 2, which will give you what? A 3. Okay, so then you take 2, plug it into the expression, you get what? 4, 2 squared plus 2, which is 6. So it gives you what? 6. Okay, now look at this. If I would go back and say from -2, our output, -2, gave us what? It is associated with 6. Our -1 in the domain is associated or mapped onto what? It's mapped onto, this is mapped onto our, this is mapped onto 3. 0 is mapped onto 2, right? 1 is mapped onto 3. Take note, look at that. So -1 and 1, they are mapped onto what? Onto 3. 2 is also mapped onto what? 6. If you plug in 2 there, you also get 6. Right, now looking at this, I'm going to say, if you were to arrange them in an ordered, in terms of ordered pairs, the same thing will come out. But look at this. I'm observing that many elements on the domain, meaning to say -2 and 2, many elements on the domain are associated with one element of the range. So this function is called a many to one function. This is a many to one function, right? Now, a many to one function is where many elements of the domain are associated with one element of the output or of the range. A many to one function. Remember the function, the definition of a function. We said it's a special type of a relation where at least one element of the domain is associated with one element of the what? Of the range. So in this case, there are many. That's why we use the at least one element of the domain. In this case, there are two associated with one output. Okay, right. So we call this a many to one function. A many to one function, right? A many to one function. We can define this. I can write it in full as one, okay, many elements of the domain, many elements of the domain are associated with one element of the range. Okay, that is a many to one function. Now, quickly, my last illustration there. Let's look at the last illustration there. I'm going to give you an expression of the form y equal to square root of x, something like that. Okay, I'll also state its domain. And on its domain, remember, I'm going to pick values at random. I can pick this to be what? 1, 4, 9, something like that. What about your range? There is my range. I'm going to say, okay, this is going to be what? Substitute 1 into square root of x. It means it's going to give you plus or minus 1 as an output. So 1 brings out plus 1 or minus 1. Right, now look at this. 4, if you plug 4 there, it will give you plus 2 or minus 2. Okay, what about 9? Definitely, it also gives you plus or minus what? Plus 3 or minus 3, something like that. Okay, so what that means is one element on the domain is bringing out two elements on the what? On the range. You only inserted 1, but you are getting 2. So what that means is this is not going to be a function. Why? From the definition of a function, we said at least one element on the domain associated with a unique element of the range. But in this case, it's no longer unique because there are 2 on the range. So one element of the domain is now bringing us many on the range. So this, we call it what? Not a function. This is not a function. So once you have 1 to many, that means it's not a function. Remember, it's supposed to be a domain input is supposed to give us a unique output, not 2 or more, right? So what that means is we can say this is not a function. Reason, one element of the domain one element of the domain is associated, or someone can use the word mapped to, associated with many elements of the range. There you go. Right. That is not a function. That is not a function. Okay. Right. Now, so just in terms of conclusion, in summarizing this, just as a conclusion and summarizing what we've gathered there, we said we are identifying, or we are concluding that there are two types of functions. A function can be one-to-one, or a function can be what? A many-to-one function. So in conclusion, we can say there are two types of functions. We only have two types of function. The first one, we call it a one-to-one function. A one-to-one function is when one element of the domain is associated with one element of the range, right? And then the second one, it is what? A many-to-one function. Okay, so there are only two, one-to-one and many-to-one. Okay, right. Now, just a quick illustration that will make you remember, dragging it to real life situations. Now, look at this. Look at this quick illustration so that you'll be able to tell a function, what is a function, and one-to-one, many-to-one, be it one-to-one or many-to-one, or where do we say this is no longer a function, just to make you quickly remember. I'm just going to give you an illustration here. A simple relation, a simple illustration that is real in your world. Right. Let me take relationships. Like, say, let's use people that are married. Right. If I come and say Susan is married to Tom. Look at this relationship. Look at this relationship. There is only one Susan married to one Tom. So we call this a one-to-one relation, which is a one-to-one function when we are talking about now your functions. Susan and Tom. Okay, right. Now look at the next one. I've got still my Susan there. And the next one, I've got Mary. Right. Susan is married to Tom. And Mary is also married to Tom. You can also add Mpo and you say they are married to what? Tom. So this is, okay, let's put Mpo also married to Tom. So this we call it a many-to-one function. That's what we are saying. Many wives associated with one husband. Okay, so this is a many-to-one function. Okay, but let's look at this one now. Let's look at this one. I've got my Susan there. Then this side, I've got Tom. Right. I also have what? Jerry. Oh, Tom and Jerry. Okay. Susan is married to Tom. And the same Susan is married to Jerry. That's a taboo in our in our societies. Susan cannot have two different husbands. So this is not a function. This is not a what? A function. One element of the domain is now giving us two outputs. Okay, right. Just to make us have a different view on our function, right? So that is not a defined. That is not a function. Okay, right. Now let's go to testing. At this stage, one is supposed to be able to identify a function when it's a drawn graph, or identifying a function when it's an algebraic expression. So at grade 12 level, when you are given a graph, you should be able to tell that this graph represents a function, or it's not representing a function. Right. Now, if it's an algebraic expression, you should be able to tell that this algebraic arrangement is actually of a function, or it is not representing a function. I'm going to start with, I'm going to look at the first thing there, which is determining a function from a drawn graph or algebraically. Right. Right. Determining whether a drawn graph is a function or not, or testing whether a drawn graph is a function or not. Okay. Determining. Right. Sorry about that. Right. Determining whether a drawn graph represents right, whether a drawn graph represents a function or not. Right. Determining whether a drawn graph represents a function or not. Right. Determining whether a drawn graph represents. How do you determine whether, once you see a graph there drawn, whether this is going to be representing a function or not, graphically? How do you represent? How do you determine? That's the most important thing. Right. For us to determine whether the drawn graph represents a function or not, I'm going to use what we call the vertical line testing. So use a vertical line test. Right. Use a vertical line test. Simple. Once you see a graph drawn, I'm going to test it. I'm going to test whether it's a function or not by making use of a vertical line test. So the next question is, how do you test? what is a vertical line test. Right. Now, the first step or step one, that is steps to follow. Step number one, draw or insert a vertical line which cuts the graph anyway. Right. If the vertical, sorry, there's repetition there. If the vertical line cuts the drawn graph once, then the graph represents, right, a function. Otherwise, it does not represent a function. What am I saying? Once you've got a graph which is drawn there, let me give you just a quick illustration on this one. Just an illustration and see how you're going to do it. Right. If I've got something like this, there you go. That's a bell-shaped parabola. You can see that. Right. Now, this is the y-axis. This is the x-axis. I'm saying if you insert a vertical line anyway on the graph, any vertical line, I can put a vertical line with those dotted lines. Look at that. How many times does this vertical line cut the graph? There, it's once. Look at that. It cuts once. Now, once it's like that, anyway, as long as the vertical line and it cuts the graph once, it means that graph represents a function. So that's why we always call parabolas quadratic functions, because they pass the vertical line test. So this is a function. This is a what? A function. Okay, now come to the next one. I can draw something on my Cartesian plane. Then that's a circle. Insert a vertical line anyway, which passes through the drawn graph. Look at that. Look at that. Look at that. Right. Does it pass the vertical line test? No. The graph cuts, the vertical line cuts the graph twice. You can see that since it cuts the graph twice, then it means this does not represent a function. Why? Because if I've got one x value there, it means it's associated, or it's going to give birth to two y values, y1 and y2. So if I insert x into the algebraic arrangement of this graph, I'm going to come up with two outputs. Then it means it is not a what? A function. But if you look at my parabola, If I insert an x value, I'm going to come up with yet an output. If I insert an x value, I'm going to get one output. Okay, so a circle is not a function. That's why you never hear someone saying a circle function. It's unheard of in maths because a circle, an ellipse is not a function. Right, I'll give you different graphs. You now know all your graphs. You can go back to all the functions that you have, test them, put a vertical line test to an exponential graph. You will see that it passes the vertical line test. Put a vertical line on a hyperbola. It passes the vertical line test. Put a vertical line on a cubic function. You always see that it passes the vertical line test. Hence, all those are called functions. But if you go to an ellipse, you will see that it fails the vertical line test. So it's never called it's never called a function. Okay, right. Now let's look at the next aspect. We've managed to show that we've managed to deduce a method which is going to help us identify what a function is. Now I want us to go further. We've got two types of functions. There is a one-to-one function. There is a many-to-one function. Right. How do I know graphically that this is a many-to-one function and this is a horizontal, this is a many-to-one function graphically? Okay, right. Now, how do I know, or how do you test that this is a what? A one-to-one. Determining whether a function is one-to-one or many-to-one. Determining whether a drawn graph which is a function, I'll put that in bracket, is one to one or many to one. Okay, determining whether a drawn graph represents or a drawn function is a one-to-one or a many-to-one function. Very, very simple, very simple, very, very simple. I want us to look at this. Okay, now, for a function to be one-to-one, first thing is, since it's a function, it's supposed to pass the vertical line test. Then it passes yet another test, which is called a horizontal line test. So it means a one-to-one function is a function which passes both the vertical line test, means say if you insert a vertical line test, it cuts once, and if you insert a horizontal line test, then it also cuts once. Then we call that a what? A one-to-one function. A many-to-one function is a function where it passes the vertical line test, but it fails the horizontal line test. Meaning to say, when you insert a vertical line test, it cuts once, but when you insert a horizontal line test, it cuts more than once. Then we call it a many-to-one function. Right? So we are saying a one-to-one function passes both the vertical and horizontal line test. Okay, right. Now, and a many-to-one function passes the vertical line test, but fails, underline the word, fails the horizontal line test. Okay, so one-to-one passes both the vertical and the horizontal line test, but many-to-one passes the vertical and fails the horizontal line test. Okay, right. So I'm going to give you an illustration. You now have different functions. Guys, you've been exposed to a linear function, you've been exposed to a quadratic function, you've been exposed to exponential, hyperbolic, and trigonometric functions. You should be able at this stage to classify them. Which ones are one-to-one? Which ones are many-to-one function? Okay, right. Let's look at this quick one. Let's look at this illustration on the one-to-one and many-to-one function. Now let's look at this one. I've got a drawn graph there, given a drawn graph below. Conclude whether it's 1 to 1 or many to 1. Now the first one is something like this. Right, I've got something like this. We can see that that's exponential function, which is generally increasing. Right, now look at that. Okay, I want to see whether it's going to be one-to-one or many-to-one. First, I'm going to insert a vertical line test. Look at my vertical line. It passes, it cuts the graph once. So it means this is a function. So an exponential is a function. What about horizontally? It also cuts once. Wherever you insert a vertical line or a horizontal line, the graph will be cut once. So this means this is a what? A 1, 2. This is a 1, 2, 1 function. Okay, right. So I'll go now to the next one, which is something like that. There you go. This is y, this is x. Look at this. Vertically, I can insert anywhere vertically. The graph will always be cut what? Once. Okay, right. So this is a function. So all parabolas are functions. What about if I insert a horizontal line test? Oh, it cut twice, that point and that point. So it means this is a what? A many to one function. What that means is, if I go to the x-axis and I draw a line, I'll be able to get an output there, which is a y value. So this x1 brings out y1. If I come this side, this is now x2. I'll come that side, this is x2. Right. If I draw a horizontal line coming up to get the corresponding y value, it's also mapped onto y1. So it means this is a many to one function. Try it even with your trigonometric functions. A sine graph is something of this sort. Right? Now, if you look at this, this is 90. This is 180. This is 270. This is 36. That's a sine graph. But insert a vertical line test. Anyway, that's it cuts once. Anyway, it cuts once. So it means it passes the vertical line test. Then it means it's a function. But when I insert a horizontal line test, remember a sine graph starts from negative infinity going towards positive infinity. I can even continue like this, right? You can even continue like that. If I insert a horizontal line, this is going to be something like that. That's a horizontal line. What is happening with the horizontal line? This fails the horizontal line test. So it means this is a what? A many to one function. That's a many to one function. What does that mean? Look at this. I've got the first x value there. It's mapped onto that, right? The second x value, which is there, it's also mapped onto that, which is the same y value. I've got another x value there, which is also mapped on the same y value. Another x value there, call it x4, x3. So x1, x2, x3, x1, x2, x3, x4, they are all mapped onto what? Y1. x1 brings out y1, x2 brings out y1, x3 brings out y1, x4 brings out y1. So it means this is going to be what? A many to one function. If you go back to your trigonometric functions or trigonometric equations, that's why you were realizing that sine 30 is half, sine 150 is half, sine 390 is half, sine negative 330 is also half, on and on and on like that. All those values, they were giving out one output. So we call them what? A many to one function. Very, very, very important. Okay, now the last illustration there is basic about what? Determining whether a given algebraic expression. Remember, I said you can do it algebraically, which and you can do it what graphically, which is what we did. I discovered that there is something which is called one-to-one function. I know how to test graphically and conclude that this is one-to-one and this is many-to-one function. Okay, let's look at algebraically. How are we going to do this algebraically? Very simple. On algebraically, uh, determining whether a given equation represents a function or not algebraically. Algebraically. Right? Algebraically. Look at this. How do I conclude that this is a one-to-one or a many-to-one or not a function algebraically? Very simple. I'm going to be picking values. Algebraically, I'm just going to sample values, then substitute into my expression. Then I'll be able to what? To conclude. Say I am given a function, the first one, like y is equal to 4x minus 3. I'm going to pick random values for x because x is independent. I'll start by saying, okay, let me say x equal to 1. What is going to be the output? The trick is use positive and negative values. Then you'll see what is going to happen. Right. So I'll start with what? Let x be equal to 1. Substitute, this is y equal to 4 times a 1 minus a 3, which is 1. Right. Let x be equal to negative 1. Substitute, this is going to be y equal to negative 4 times negative 1 minus a 3, which is going to be what? Negative 7. What is happening? A unique x value brings out a unique output. A unique input, unique output. So this means it's what? 1 to 1 function. One element of the domain, one unique element of the domain associated with one unique element of the range. Right, let's look at the next illustration there. I've got a function like y equal to 2x squared minus 1, something like that. Remember I said when you're testing algebraically, you are inclined, or we are supposed to strategically pick a positive value and its negative value and see what is going to happen. So I'm going to say let x be equal to 2 and compare it with let x be equal to -2. Someone can use -10 and 10, someone can use -5 and 5, someone 1 and -1, still the same. So you say let x be equal to that. Evaluate what is going to happen. This is 2 squared minus 1. This should be 8 minus that, which is 7. Now come to this one. Substitute as well. This is going to be what? Y equal to 2 times -2 all squared minus 1, which is also 8 minus 1, which is 7. What are you noticing? Two values of x mapped onto one element of the range. So we call it a what? A many to one function. Okay, what about C? Look at C. I'm given as y equal to square root of y equal to the square root of x, which is something like that. Let x be equal to 9. This becomes y equal to, you don't need two values there. You can say y equal to what? 9, which is plus or minus 2. Oops, 2 outputs. So it means this is going to be what? Not a function. This is not a function. Why? One element of the domain is associated with many elements of the range. Right. So guys, we've managed to go through the first section, which is very, very important on your functions and graph, just to be able to define what a function is. A function is where one element, at least one element of the domain is associated with at least one element of the range. Okay, right. At least one element of the range is associated with a unique element of the range. Okay, right. So what that means is anything which shows that one element of the domain brings out a unique element of the range, it means that is a function. Anything which goes vice versa, it means it is not a function. Under functions, we've managed to identify that there's something which is called one-to-one function, and there's something that which is called a many-to-one function. Sorry, right. So one-to-one meaning one element of the domain associated with one element of the range. Many-to-one, many elements on the domain associated with many elements on the range. Once it's one to many, then it's not a function. You should be able to test graphically, and you should be able to test algebraically whether the graph drawn represents a function or not. If it's a function, is it many to one? Is it one to one? Right. And also algebraically, right? I'm going to post an activity. Please see to it that you go through this activity and apply the knowledge that I gave you to go through this. Thank you so much. Let's meet in the second lesson. Look out for the activity that comes with this presentation that I made. Thank you so much, grade 12. Let's unpack this together. I'm going to be posting more and more videos on this aspect of functions. It's a very simple aspect, but yet you need to do yourself nicely. Enjoy your studies. Goodbye.